Hey, what's going on, guys? So today we are going to start Unit 7, Similar Triangles. Uh, we are going to start with 7.1, which is ratios and proportions. So ratios are a comparison of two or more quantities. There are three main ways to represent ratios. One of them would be uh, as a fraction, such as A over B. You could also write A to B. And third, the most common way is A colon B. Okay, and ratios can always be simplified. So let's look at some examples. So a music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. Write each ratio in simplest form. Let's just do number one. So trumpets to violins. So realistically, you can use any of these three forms to write it. I'll just choose colon. It's the most commonly used notation. So trumpets to violins. So there are 40, okay, 40 trumpets and 24 violins, okay? But keep in mind, just like as if it were a fraction, this does simplify, right? You can take an 8 out of both of these, and you'll have 5 to 3, okay? So you should always simplify because the simplified version basically kind of gives you the most information. It's saying that for every 5 trumpets, there will be 3 violins. Okay, keeping it as 40 to 24 is kind of weird. Realistically, you would want to put it in its simplest terms. An extended ratio is a comparison of 3 or more quantities. And in this case, there's really one notation, and it's the colon notation, A to B to C. Obviously, and this is why colon is the most common notation for ratios. Clearly, as soon as you get to 3 or more, especially, it's just weird to try and write that as a fraction or to keep writing 2 in between everything. Colon is just the easiest form to do. Um, let's take a look at number 5. So it says the ratio of two complementary angles is 3 to 7. Find the measures of both angles. So, okay. So one, recall that complementary angles add up to 90 degrees. And then it says that the ratio is 3 to 7. Okay? Meaning that for every 3 degrees one has, the other has 7 degrees. We don't know how many degrees each one has, so that's an unknown. So say x instead. So think of it as 3x and 7x. For every 3 degrees one has, the other has 7. So we can just write this as 3x plus 7x equals, and then that 90 degrees. Okay, this adds to be 10, so 10x equals 90. Divide your 10 over, x is 9. Now the important thing is, yes, we found x and that's great, but it did ask us to find the measures of both angles. So for that, we just plug in x for 3x and 7x. So one angle would be 3 times 9, which is 27 degrees, and the other would be 7 times 9, which is 63 degrees. And 27 and 63, those do add up to 90, so this checks out. Okay, on to the next. So on to proportions. Proportions an equation that states two ratios are equal. Okay, so the proportion can be written as something like this: A over B equals X over Y. Okay, so again, it's essentially just two fractions set equal to one another, or two ratios. So a property to not forget is the cross product property. So for any proportion, you just cross multiply and rewrite it as, in this case, A times Y equals B times X. So let's look at a couple of examples. Number 11, again, every time you see this, you're just going to use cross product property. So 4 times 7 is 28, and that equals 2 times x, which is 2x. Divide your 2 over, and x equals 14. Going on to scale factor. So the scale factor is a ratio that describes how the dimensions in a drawing are related to the actual dimensions of the object. Okay, so the scale factor, this is very commonly used in like maps. So that's a classic example, which is what examples 17 and 18 are. So let's take a look at 17. So it says the scale of a map is 1 inch for represents 4 miles. So 1 to 4, 1 inch to 4 miles. Find the actual distance from Katy to the Houston Zoo if the distance is about 7 inches. So something nice to do first is to set up a rule. And by that I mean this. I'm going to say inches over miles. Okay, that's my rule. Okay, so what I'm given is 1 inch represents 4 miles, and I'm going to set that equal to, and then I'm keeping inches in my numerator. That's my rule. So they give me inches, and they want me to find miles, which is what I'm missing. So now I just do the cross product property, and I'll have that 28, 7 times 4, equals 1 times x, which is just x. So x is 28 miles. So note, this would work even if you had all of these flipped. You just have to be consistent. So if you wanted to do miles over inches, that's fine. Both of these fractions would just be flipped, and it would be the same thing, and you'd get the same answer. Moving on to 7.2, similar polygons. So polygons with the same shape, the different size, are said to be similar if and only if these two conditions are met. Their corresponding angles are congruent, and their corresponding sides are proportional. So don't have to be the exact same number, but there should be a common scale factor. So the ratio of the corresponding sides is called the scale factor. And if the polygons are similar, then their perimeters are also proportional. This is really just kind of like a corollary to similar polygons. Basically, it's just us letting you know that basically you would never have to really find the ratio of perimeters. It would just be the same ratio as their sides, because scale factor is closed under addition, is what we'd say in more abstract math. So taking a look at some examples down here. So we have triangle ABC, triangle DEF. And it says, what is the scale factor going from triangle ABC to triangle DEF? So the wording of this is important, and it does matter. You have to look at where you're starting and where you're ending. What is your original or old, and what is your new? Okay, and then to set up the scale factor, we wrote this here for you, new over old, or to over from, same thing. So we're going from here, triangle ABC, to here. So this one is our original or our old. This is our new. Okay, so what we do is just take a ratio of corresponding sides from the two different triangles. So we must choose a corresponding side. Geometrically, the most proper way to do this is just, well, like angle A is congruent to angle D. We know that because it has one swoosh on each of them. And the corresponding side for A is 10. The corresponding side for D is 15. So 15 and 10 are corresponding sides, and this is our original, so it will go in the denominator. So we can say 15 over 10, and then simplify that to 3 over 2. Okay. Now, intuitively, this makes sense, okay, because we're going from a smaller triangle to a bigger triangle. So our scale factor is a fraction that's bigger than 1. That makes sense. And also keep in mind that this ratio is the same for any of the corresponding sides. And really what it's saying is that starting at 10, if I multiply 10 by the scale factor, 3 over 2, I end up with 15. And that's true. 10 times 3 is 30 divided by 2. That is 15. And it should be that way and work that way for all the sides. Also, a shortcut too is if we're given all three sides and assuming nothing's weird, you can also think of this as the small, medium, and large side, and this is the small, medium, and large side on this triangle. And so small goes to small, medium to medium, large to large. Now going the other way, it says, what is the scale factor of triangle DEF to triangle ABC? So we're just going the other way. So you could probably already guess how that scale factor is going to work. It's just going to be the inverse. And you'd be correct. So now we're starting at triangle DEF, and we're going to triangle ABC. So taking the same corresponding sides, 15 and 10, now 15 goes at the bottom, 10 goes at the top. This is 2 over 3. Intuitively, this makes sense. Okay, we're going from a big triangle to a small triangle. It makes sense that our scale factor is a fraction less than 1. And again, 15 times 2 over 3 is 10. 15 times 2 is 30, divided by 3, that is 10. Next, what is the ratio of the perimeter of triangle DEF to triangle ABC? Well, we told you right here that the perimeters are also proportional. And in particular, it is the same proportion. So we already found the proportion of triangle DEF to ABC above. So it is the same proportion. Then it says, a valid similarity statement must match corresponding angles and sides. Write a triangle similarity statement for the triangles above. Okay. So we have triangle ABC and triangle DEF. So for the first triangle, it actually doesn't really matter the order you write it in, but psychologically, since it's the alphabet, I'll go in order of triangle ABC. And then similar to, so we put the tilde, that's the sign for similarity. And then for the next triangle, it does matter the order that we put it in. So we need to make sure that our angles match up and sides match up. But if the angles match up, the sides will automatically match up as well. So by that, I mean this. Angle A is first here. The angle that's congruent to that is D. So we start off with triangle D. B is 2 swooshes here. That's congruent to E over here. And then angle C right here is 3 swooshes, and that matches or is congruent to angle F here. So A is congruent to D, B is congruent to E, C is congruent to F. That's the way that works. And then also more in particular, the sides match up too. Side AD or AB, okay, which is this side, matches side DE, okay, which is true. This is the small side for both. And then BC, medium side, is congruent to EF, yes, medium side. And then AC here is congruent to DF here. So everything matches up. So we can look at something like this, list all congruent angles with a proportion that relates to the corresponding sides. So when you get really good at this, you can really do this with just the similarity statement with no sketches of any triangles needed. But we're still learning, so of course nothing wrong with taking advantage of what's given to you. But so J is congruent to P. K is congruent to M. And L is congruent to angle N. Okay, now for the sides, some of these markings are really ugly. Okay, and then for the sides, we can use the triangle similarity statement. So it wants us to set the proportions, meaning it wants us to say like small over small is congruent to medium over medium, which is congruent to the large side over the large side, basically these corresponding sides. So side JK here is congruent to side MN here, so we can set up that proportion. So JK over PM, which is going to be congruent to side KL, side MN, which is congruent to side JL, side PN. Okay. Lastly, number 2, the figures below are similar at the scale factor of 2 to 3. Find the value of x. So the scale factor is 2 to 3, or 2 over 3. Okay. This fraction is less than 1, meaning we're probably going from big to small. You could also think of it as the fact that 2 is the small number, 3 is the larger number. Okay, and on the bigger shape, we have x, so bigger or larger shape x, smaller shape 42, and again 2 is the smaller number, so 42 and it go together. And then cross multiply and divide. So 42 times 3 is 126. That equals 2 times x, which is 2x. Divide your 2 over and you get 63. And that's it, guys. Thank you.